Good morning, ladies and gentlemen. I hope this recording of notes finds you well. And I hope that the last installments of notes, which introduced you to macroeconomics, is you have managed to access it. I would like to take this opportunity to move on to the next topic, as promised in the previous set of notes. The next topic that we are doing, or the second topic that we are doing, is national income determination, which is divided into three parts. According to our course outline, national income determination is divided into number one, the simple Keynesian model, which covers the multiplier principle and the combined multiplier accelerator interaction. And then we've got theories of consumption. And finally, we've got the ISLM-BP model of national income. So I'm going to present the course outline, that part of the course outline that we're going to cover under this topic. As you can see, under topic number 2, which is national income determination, we are looking at the simple Keynesian model. Under the simple Keynesian model, we are looking at the multiplier principle and the accelerator principle. Number 2, theories of consumption. Number 3, we are looking at the ISLM-BP model of national income. On completion of this topic, I'm expecting students to be able to use the graphical and algebraic approaches to derive the equilibrium level of national income within the context of the simple Keynesian model. And I'm expecting you as my students also to be in a position to explain the multiplier principle and also to identify and explain the three main theories of consumption within the context of national income determination, which have been advanced since the 1950s, 1960s, to explain a paradox within the context of aggregate consumption, which we are going to explore. And I'm expecting you as my students to be in a position to explain and to demonstrate the ISLM-BP model of national income. So right now, I'm going to cross over to the lecture slides of the simple Keynesian model. You realize that the simple Keynesian model is one of the basic models that is used in macroeconomics to explain how national income is determined. So we are looking at national income determination. So in this topic, we want to look at the simple Keynesian model. But after covering the simple Keynesian model, we transition to the aggregate demand, aggregate supply model. And we'll also look at the neoclassical model. The simple Keynesian model is based on the seminal works or the celebrated works of the British economist called John Maynard Keynes, whose views gained prominence or currency in the 1930s and 1940s during and after the Great Depression of 1929. The influence of Keynes actually led to the creation of the twin Bretton Woods institutions of the International Monetary Fund and the International Bank of Reconstruction and Development, which is normally called the World Bank. The simple Keynesian model is based on the notion of the circular flow model of national income, which we covered under the previous topic. The assumptions of the simple Keynesian model are: number one, the economy is assumed to be having two sectors, namely households and firms. Number two, we assume at the basic outline of this model that there is no government sector, though we relax this assumption just like we relaxed the first assumption. Thus, the basic simple Keynesian model assumes that there are two sectors in the economy, which implies that we can't analyze government spending and taxes. We assume that the rest of the world sector or international trade does not exist. We assume that prices such as wages, interest rates, exchange rates, and so on are given. In other words, they are fixed at their predetermined levels. Hence, the model cannot be used to study inflation directly. Wages are also assumed to be given, together with the rewards or the cost of the other factors of production. Hence, the model cannot be used to study the operations of the labor market. Assumption number 6, money demand and money supply are assumed to be fixed or given. This implies that we can't use the simple Keynesian model to analyze the dynamics of financial markets and the monetary policy. The 7th assumption is that spending in the macroeconomy is the chief driver of economic activity. So at the basic outline, we start by examining what is known as the consumption function. The consumption function is a mathematical relationship between aggregate consumption in the economy, which we explored under the first topic, and the aggregate level of economic activity, which here is represented by capital letter Y, or which just stands for national income. This first function, C is equal to F of Y, is called an implicit consumption function. The one just below it, C equals C small cy, is called an explicit consumption function. This C is equal to small cy is a long-run consumption function because there is no vertical intercept to this consumption function. The vertical intercept is 0. And then when we are looking at the fourth bullet, we see a short-run consumption function where we have got the aggregate consumption having two major components: the autonomous consumption part, which is represented by small letter a, and the income-induced consumption part, which is represented by cy. The small letter a part, the autonomous consumption part, does not change with changes in national income. The component of aggregate consumption, which changes with changes in national income, is cy. this last part, or this second part, CY, is the one which explains the changes in aggregate consumption. But if you substitute 0 here as the level of national income, you realize that even at 0 level of national income, households are able to consume, the assumption being that they will be running down previously accumulated savings. So when you look at capital letter C, it stands for aggregate consumption, which here is just named as consumption. And then capital letter Y stands for national income, which here is identified as income. Small letter y is autonomous consumption. That is consumption which is independent of national income. Small letter c stands for the marginal propensity to consume, which is the proportion of national income which is devoted to aggregate consumption, ceteris paribus. So on slide number 7, we see a simple consumption function, which is given as C is equal to 5,000 as our autonomous consumption, plus 3/4 of Y, 3/4 of Y being the income-induced part of consumption. So halfway between 0 and 10,000, we've got 5,000. And then this 5,000 would produce a horizontal line, which represents autonomous consumption, which obviously does not change since it's autonomous or independent of changes in national income. It doesn't change as expected income increases and or decreases. But the income-induced part increases ad infinitum as national income increases. On slide number 8, what we see is that from the short-run consumption function C equals to 5,000 plus 3/4 of Y. If we introduce changes, we'll have delta C equals to 3/4 delta Y, because 5,000 is a constant, its change is 0, so it disappears. Now, if we make delta C over delta Y the subject of the formula, we get 3/4. Delta C over delta Y equals to 3/4. It is this delta C over delta Y which is called the marginal propensity to consume. So in general, delta C over delta Y is expected to be a positive fraction, or it is always a positive fraction, which lies between 0 and 1. Why? We don't expect the change in consumption to be 0, neither do we expect the change in national income to be 0. And since there will always be savings which are taking place, that is, some economic agents, they normally save part of their income. They don't consume all of it. It stands to reason that the numerator delta C will always be smaller than the denominator delta Y, which implies that the resultant figure, or the resultant number that you get after calculating delta C over delta Y is a positive fraction which lies between 0 and 1, since the numerator is smaller than the denominator. And then we introduce the savings function, because in a normal economy, the savings are necessary to provide for investment spending. You need at least one leakage, which is savings, to facilitate at least one injection, which is investment. Savings can be expressed as S is equal to minus autonomous consumption plus SY, where minus A is simply the negation of autonomous consumption, which is just saving, plus SY, S being the marginal propensity to save, and Y, capital letter Y being national income. So if we introduce changes again to the simple savings function, we get delta S over delta Y equals to small letter s. Small letter s delta Y. And then we've already calculated, we omitted a stage. The first stage was supposed to be delta S equals to S delta Y. And then we divide both sides by delta Y to remain on the right-hand side with small s being equal to delta S over delta Y. And this delta S over delta Y is what is known as the marginal propensity to save. Since in the two-sector economy, income is either consumed or saved, this implies that Y is equal to aggregate consumption plus savings. So if we add the two functions, capital letter Y is equal to A plus CY, which is our short-run consumption function, plus minus A plus SY, which is our savings function, which we introduced a short while ago. Grouping like terms together, we get capital letter Y being equal to A minus, we get capital letter Y being equal to A minus A plus CY, this part, plus SY. A minus A is 0, and then we are left with Y is equal to CY plus SY. And then we factorize Y to get Y factor of C plus S. Remember that A minus A is 0, so it is degenerated. The A is no longer there in this function. So we now have Y is equal to Y factor of C plus S. And then we divide both sides by Y to get Y over Y equals, open curly bracket, Y factor of C plus S, close inner bracket, close curly bracket, all over Y. And then we get 1 being equal to the Y is eliminated from the right-hand side. So we get 1 being equal to C plus S. That is the marginal propensity to save plus the marginal propensity to consume equal 1 in a simple two-sector model. So graphically, to outline an exposition of the simple Keynesian model, we introduce a tool which is known as the 45 degrees line, which sort of bisects our positive quadrant, where we do much of our reasoning when we are presenting the simple Keynesian model. Along the 45 degrees line, given that we've got consumer spending, which just stands for expenditure in this economy, and then we've got real disposable income, which stands for national income. Along the 45 degrees line, since it's a line of symmetry, a line which bisects the positive quadrant, Y, which is on the vertical axis, which is on the horizontal axis, equals A, E, which is on the vertical axis, AE, representing aggregate spending in the economy. So along the 45 degrees line, there is equality between the level of national income that is existing and the aggregate level of expenditure. So the savings function graphically is given as S is equal to minus 50 plus 1 quarter Y. The graph is as follows. We start from minus 50, and then we maintain a slope of 1 quarter Y, and it gives us the graph which you are seeing. Since there are firms in the two-sector model, this implies investment as an injection. This yields the following aggregate expenditure function. So we've got consumption, expenditure, consumer spending, plus investment, which sort of shifts the consumption function upwards parallel to itself to get the green curve, which is our aggregate expenditure in this economy. At the intersection of C plus I and the 45 degrees line, we get equilibrium level of national income. So aggregate spending is the total amount of goods demanded in an economy by all the people who demand output. The aggregate expenditure function can be expressed as follows. AE is equal to C plus I, where capital letter C stands for aggregate expenditure for consumer goods, and the I stands for aggregate expenditure for capital or investment goods. The fundamental equations in a two-sector economy are given as the consumption function being equal to aggregate consumption being equal to 400 plus 0.75y. And then investment spending is assumed to be 400, maybe 400 million or 400 billion. You are required to ascertain the following: the equilibrium level of national income and the equilibrium level of consumption. That is aggregate consumption at the equilibrium level of national income. In a two-sector economy, the equilibrium level of national income, Y, is equal to 1 over 1 minus C. This 1 minus C is nothing, it's none other than the marginal propensity to save plus the sum of autonomous expenditures, which in this case is autonomous consumption and investment spending, which is not in any way related to national income, as you see that it is fixed at $400 million. So from the given equation, this formula, plugging in the relevant things, we've got 1 minus 1 over 1 minus 0.75, all multiplied by a factor of A. Our A is 400 plus I with a power, which is also 400. So it's 1 over 0.25 multiplied by 800. Multiplied by 800, which is what you are seeing here, which gives us 3,200 or 3.2 billion. In the two-sector economy, the consumption function is simply A, which is C is equal to 400 plus 3/4 of Y. Since our Y is 3,200, we simply substitute 3,200 into the consumption function to get 2,800. So at an equilibrium level of national income of 3,200, the total level of consumption is 2,800, with the 400 million, with 400 million representing the savings that are taking place in the economy. Because what is not consumed is saved, and what is not saved, it is consumed. We want to examine the multiplier process or effect and how it operates. It operates if investment, which is exogenous, if we have investment which is exogenous, which either increases or decreases in an economy, and thus affects national income. So if investment increases from $150 billion to $250 billion, the increase is 100 billion. So if we assume an initial level of national income of 2,600 billion or 2.6 trillion, the multiplier effect or process is shown on the next slide. So what kickstarts the multiplier process is the initial change in an autonomous expenditure of 100 billion, which is what we postulated on slide number 18. So this initial change in investment of 100 billion is distributed as the change in consumption of 75 billion, according to the marginal propensity to consume, which is 3/4, and an initial change in savings of 25 billion. In the second round, we have 75 billion fitting into the second round. 3/4 of it is 56.25, and 1/4 of it is 18.75. And then we have 56.25 contributing to the third round. Its 3/4 being 42.19, and 1/4 being 14.06. And then the 42.19 of the third round becomes input to the fourth round as a change in national income. Its 3/4 is 31.64, whilst the 1/4 of 42.19 is 10.55. And then the process continues to infinite, but as we can see, what is contributed to the next round, it decreases. And all other rounds, they actually contribute 126.56 in terms of the change in national income. This kind of progression or process is called an infinite geometric series. And under infinite geometric series, this one is a convergent, not a divergent geometric series. So we use the formula for summing such a series, which is presented on slide number 20. So generally, the total change in national income is found by using the following formula for summing an infinite geometric series, which is convergent. Capital letter S, which is the sum of the entire series, equals to capital letter A, which is the first term or the initial change in an injection, divided by 1 minus R, where R is the common ratio or the marginal propensity to consume, which links the figures in different stages or rounds of expenditure. So contextualizing the formula to our current situation, capital letter S is simply the change in national income, the composite change in national income, or the total change in national income, or the summation of the change in national income. Not just the change in national income in one round, but the overall or total change in national income, which is equal to capital letter A, which is simply the change in investment in our scenario, 1 minus divided by, open brackets, 1 minus R close bracket, where small letter r is the marginal propensity to consume. So in the final analysis, we've got 100 divided by 1/4, which gives us 400 billion, where 1/4 is obtained from 1 minus 0.75. So an initial change in an injection investment of 100 billion yields a change in national income of 400 billion, meaning to say there is a multiplied rise in national income. In general, the final level of national income is calculated as follows. Y subscript final is equal to Y initial, which is 2,600, plus delta Y, which is 400 in this case. And we get the final level of national income being 3,000 billion, which is 3 trillion. From the foregoing analysis, we can deduce that the multiplier K is expressed as follows. K is equal to 1 over MPS. In other words, the multiplier K is the reciprocal of the marginal propensity to save. It is noteworthy that from the savings function, our marginal propensity to save is nothing but 1/4. So the reciprocal of 1/4 is 4. which is why our multiplier is 4. 4 multiplied by 100, it gives us this 400. Without this formula for summing an infinite geometric series. So another way of calculating the multiplier is simply to say the multiplier k is simply the change in national income. I'm going to correct that. It is simply the change in national income over the change in investment. It is the change in national income over the change in investment. Let me correct that. The multiplier K it is simply the change in national income over the change in investment. So I'll go back to the presentation again to share with you the screen. So the multiplier K is simply delta Y over delta I, which is 400 over 100, which gives us 4. So national income in a closed economy with government, we've got one injection G and one withdrawal T, which are added to the economy. So aggregate expenditure is now made up of 3 things. It's a composite of consumption expenditure, investment spending, and government expenditure, where capital letter T is the total level of taxation and is equal to the marginal propensity to tax multiplied by the level of national income, where small t is the marginal propensity to tax and capital letter Y is the level of national income. If taxes are levied on economic activity, then aggregate expenditure is determined by a change in disposable income as opposed to a change in national income per se. So our disposable income YT is simply equal to Y minus capital letter T. But recall that capital letter T is simply TY. So YT is simply equal to Y minus TY. And then we factorize Y. And we get YT being equal to Y factor of 1 minus T. So 1 minus T is the marginal propensity not to tax economic activity or not to extract part of the income which is circulating in the economy to facilitate government activities through taxation. Given that YT is equal to Y minus TY, this means that YT equals 1 minus T in brackets Y, factor of Y. So our consumption is now equal to autonomous consumption plus, which is small letter a plus C, YT instead of Y, because we now have the government which is levying taxes on economic activity, which affects our aggregate level of consumption. Substituting YT, we already know from the previous stage that it's equal to Y minus small letter t factor of Y. So if we substitute that part, we get aggregate consumption being equal to autonomous consumption plus C factor of 1 minus T factor of Y. If we assume that government is exogenous, since it is determined by government policies, that is government spending, then we have got aggregate expenditure being equal to C plus I plus G, where C is nothing but what we got in the preceding stage as A plus C factor of 1 minus T factor of Y plus I plus G, which are autonomous. So if we group like terms together, we group autonomous consumption together with I and G, we get A plus I plus G being our vertical intercept, plus C, factor of 1 minus T multiplied by capital letter Y, which is the income-induced part of consumption, of aggregate expenditure, I mean to say. So at equilibrium, Y is equal to AE. If we, and our AE is from the previous slide, we know that our AE is simply A plus I plus G being the vertical intercept plus the income-induced part, which is C factor of 1 minus T multiplied by Y. So if we group the terms with Y together, we take this part which is income-induced to the left-hand side. It crosses the equal sign and acquires a negative sign as minus, open brackets, 1 minus T factor of Y. And then if we factorize Y, we get 1 Y curly bracket 1 minus C factor of 1 minus T equals A plus I plus G. So after doing our mathematics, we realize that capital letter Y is equal to A plus I plus G multiplied by 1 over 1 minus C factor of 1 minus T. The other part is the multiplier for a closed economy with government, which is levying taxes. So K equals to 1 over 1 minus C factor of 1 minus T is a closed economy multiplier with government, which is levying taxes. If the government does not levy any taxes, the multiplier will still remain the same as the two-sector economy multiplier, which is 1 over 1 minus C, or simply K is equal to 1 over MPS. So K, when the government is levying taxes, is smaller than K when the government is not levying taxes. If our T is 0.3 and our MPC is 0.72, you can experiment, you realize that the K, where the government is levying taxes, is smaller than the K, where the government is not levying any taxes. So the open economy multiplier, we are going to explore it in a tutorial. So thank you so much, ladies and gentlemen, for attending this first set of lectures and going through the slides together with me. I'm going to email the slides during the course of the week. But just follow the video, the explanations that I gave on the video. Thank you so much for listening in.